worked with superconducting magnets in the lab for the last 25 years. So I came across this new wire, 12 millimeters wide and about 0.1 millimeter thick. So it's very, very thin. It's just this strip soldered with normal electrical solder together to make a square. And I've tripled it. So there's 3 layers of this thin foil soldered on top of each other crosswise. And what we do with this, we want to have this in a superconducting environment, meaning it has to be at minus 180 degrees, which means we'll immerse it in liquid nitrogen. I put a piece of copper underneath to lift it off the foam so the liquid nitrogen can get underneath and keep this whole lot cold. So this is just basically a little table. Here's a very strong neodymium magnet. I painted some white lines on it so you can see more. No magnetism here, it's not magnetic. No magnetism here. Put my liquid nitrogen in here now. The white stuff you see coming off is just condensation because it cools the air. It will fizz and bubble a bit until this thing is at minus 180. The cold has to penetrate through the metal and it has to really cool down evenly. And then we'll see what is called magnetic levitation. When I put this magnet onto that plate, which has now become superconductive, meaning it has no resistance to electrical current. Something strange happens when we put a magnet near it, and that this can be done with any magnet. It can be a very strong one like this, or even a weak magnet, fridge magnet, and the superconducting material will repel any magnetic field, meaning the magnet, if it's strong enough, will float. The nitrogen in here is about half a cupful, will last us about half an hour. So now I'll just see how good, see how steady it is. I'll just place it there, hold it. My fingers are close to the liquid nitrogen but not in it. And the magnet is floating about 15 millimeters from the plate. And it's about 10 millimeters above the liquid nitrogen. I can put that under it, it's floating. And if I use a round magnet, I can spin this and it will happily spin for a very, very long time. It will eventually stop. And the gentleman I saw this had a square magnet. It would spin for a little bit and then would stop. Square magnets don't spin very well, they just stop. And the interesting thing with this is floating magnetic levitation has been observed with other materials. What is special about this is there's what's called pinning of the magnetic field, which means this is locked. I can move this. It's quite hard. It's like stuck in firm jelly. I can lift this up and the plate just comes with it until it warms up and then it falls down. I'll just let that go. So I'll just put that back.
Is the magnet cold?
The magnet is still reasonably warm. If I want to get it off, I have to hold this plate down and pull it up. So the magnet is cool, maybe 0 degrees. And I can put it in this direction and it repels it. I can turn it around. It'll repel it and it'll spin if I wanted to. And I can put it like this. I have to hold it a little bit, it needs to settle, and then it sits there. I can put it in any direction. I can put it in at an angle, like so. It will sit there. I can put it in at that angle, and it'll sit there, and it'll spin. This is nice and round. I can put it near the edge of the plate. It will sit there. No, it falls off. Too close to the edge, the effect is not there, it'll fall off. So it has to be somewhere near the center but not perfectly centered. So it will sit there for as long as this stays cold. If I keep topping up the liquid nitrogen, it will sit there for 6 years. It will not move.
It seems to start oscillating too.
Yeah, this is what I found out by accident. I was mucking around with this at home when I first got it. I soldered up the plate and put it in, and I realized that it was spinning. I turned around to get some tools, and when I came back, it was spinning like this. And I didn't notice, or I didn't remember making it spin, so I stopped it. Now the plate, it has to be relocked. Just put it like this. Now hold it a bit till it gets locked in. And then I observed it for a bit. And after a while it was spinning again. You'll see it oscillating a little bit. Now we could stay in here for about 10 minutes and then it will start spinning. That's boring. So what I'll do, I just spin it a little bit by hand. Or I'll just put it on again. I put it on a little bit off center. No, not doing it. Turn it round the other side. Hold it centered. Now it's oscillating a little bit more. And this movement will become more and more. If you're patient, you can just watch it. Another 0.5 millimeter, another 0.5 millimeter. And at this rate, my estimate, it will take about 3 minutes before it'll start spinning. I've had lots of people look at this, scientists and non-scientists, technical people and non-technical people.
Made its first revolution.
There we go.
There seems to be a resistance point and it breaks through it.
Yeah. And it can spin left way round or the right way round. It doesn't seem to matter. It will spin in any direction. It'll spin in any location. I've had it in various different houses, places, indoor, outdoor, daytime, nighttime. It spins whether it's hot or cold. I've had the magnet in the car at nearly boiling point, like 40 degrees. It spins at 40 degrees. It spins when it's minus 180. It doesn't make any difference whether the magnet is cold. This magnet is magnetized, so we say we're looking at the North Pole and that's the South Pole, or vice versa, so it's magnetized through the flat part, so North Pole, South Pole.
So the axis of the pole goes through the hole in the center.
Yeah. And only a magnet like that will spin. Round magnets may spin. Any shaped magnet will float.
And it seems to have a differential rotation, like speeding and slowing.
Yes, that's a strange thing. It seems to be some restriction. I can stop that. I'll just stop that and let go. So we have a little bit of motion here, and this will get stronger and stronger. I'll just turn that on a bit more because it's boring sitting here waiting for it to do that.
And there is a sort of orientation.
So just look at this. It goes halfway around, then stops almost, and it goes a little bit further.
Yeah.
All the technical people I've spoken to had various ideas about thermal.
Oh, I just made it.
Thermal things.
Oh.
I've had this sitting here and ice up. Like at the moment we have very dry air in here. If you just put that on, you see a little bit of ice forming at the edges. I've seen it sitting in there. Like if it's outdoors and you've got a bit of a breeze blowing, there's humidity coming over the top and it will frost up the magnet. And I've seen it with a lot of ice on one side of the magnet and the other one was ice free and it would still spin. It would happily spin with a 1/2 teaspoon of ice on one side. But